Okay, so a few of you have emailed me questions about the R1 to R4 lab that you did last week and asked me to run through a few of the problems in this video. So I'm just gonna kind of sketch out a few of them. Nobody told me any problems in particular, so I'm just gonna pick 4 or 5 of them. And if there are any other problems, either on homework or labs throughout the semester that you have questions about, email me and I'll gladly make more videos to kind of go over them. But if there's any problems in particular that you wanted me to go over, make sure to mention that so I actually go over the problems you care about if there's just something you're really confused by. Otherwise, like I said, I'm going to assume it's more of a general conceptual question, so I can just pick several problems or make up problems and go through them. So, starting at the top, suppose we have for question number 2 on the front side of the page. For A, we have AB cubed to the 5th. And as far as it goes, the goal of this is to know all of the properties of exponents and to make sure we're clear on them. So for the purposes of this, we have 2 main rules that we care about, and I'm making sure I stay on the screen so you can see me. If you have something like a to the x to the y, if you raise an exponential to a power, the rule is you multiply the powers together. So if you have 2 squared cubed, that's an exponential raised to a power, so you get 2 to the 2 times 3, 6. The other rule we're going to need is if you have a to the x times a to the y, if you multiply 2 exponentials together, you add the powers. So this becomes a to the x plus y. So if we had 2 squared times 2 cubed, you get 2 to the 2 plus 3, 5. And you can actually plug this into your calculator and get the numerical values of this one and that one out. And then you can actually see that it works. But as far as it goes, these are the rules. For this one, it's slightly different. Here we have a product inside the parentheses, a times b cubed to the 5th. And again, there's another rule that says if you have maybe a times b to the x, then you bring the x into each of the powers. Both of these are raised to the 1 since we don't have a power listed. So this x comes into this and that. So if you want, you could rewrite this as a to the 1 to the x, b to the 1 to the x. Now the rules of exponents say raise an exponential to a power, multiply the powers. So this would become a to the 1 times x, which is x, b to the 1 times x, which is x. So essentially, this power goes into both of these. So now I can apply my rule. I'll do it right here. This is an exponential raised to a power. So I get a to the 1 times 5, 5. B to the 3 times 5, 15. And that's my answer. And again, all we're doing is, I'm making sure this is clear. Yeah, you can see that. Good. And on YouTube, you can also zoom in. Good. And all I'm doing is applying the property. For the next one, checking the time so I'm not late for my next class. Okay, good. Checking the next one. So 2b, I guess. We have 2xy to the 4th cubed times wy cubed squared. Oh, and also I will say as far as this goes, semester by semester, students seem to vary. Some watch these videos on their computer, some watch them on an iPad, some watch them on their phone. So it seems like some students prefer it if I do the camera vertically, other ones prefer if I do it horizontally. So there's kind of a mix and match for the videos that I've done. If you have a preference, feel free to let me know. This one I'm doing horizontally, so we have a lot of board space, but I can do it either way. So here, as far as rules of exponents go, these are 2 separate things. So we work with this, then combine them. Here, same thing. We have an exponential raised to a power, so we bring the power in. One key point to remember, the 2, the x, and the y are all separate. So the cube goes into each of them. So I end up getting 2 cubed, x, there's no power, so that's to the 1. So 1 times 3, 3. Y to the 4 times 3, 12. Do the same thing here. That's y to the 1. Rules are exponents, raise the exponential to a power, multiply the powers, so I get w to the 1 times 2, 2, y to the 3 times 2, 6. Now I can simplify this. 2 cubed is 2 times 2 times 2, which is 8. There's only an x cubed. For the y's, there's a y to the 12th and y to the 6th. If I multiply two exponentials together, I add the powers. So this becomes y to the 12 plus 6, 18. And then I get w squared. That's simplified as much as I can go, so I'm good. One more like this on the front side. This one. So suppose I have, this is 2d. Suppose I have 3 over x to the negative 3. And as far as it goes, negative exponents, we actually won't see them much in this class, but you do have to understand them and they do pop up occasionally. And the rule is, if I have x to the negative a, that's equal to 1 over x to the a. Essentially, negative exponents become reciprocals. So if you have 2 to the negative 3, that's 1 over 2 cubed. And then you can get 1 over 8. But essentially, in your head, it means negative exponents are reciprocals. So here, this is 2 to the negative 3 over 1. You flip it to make it positive, but it also works backwards. So here, there's a negative exponent in the denominator. So to make it positive, you flip it. The 3 will just stay in the numerator, but now that becomes a positive 3 in the numerator. And you just get that. One other thing I will point out as far as it goes, both of these are the exact same thing. Technically, all of these are the same. Like this is the same as that, this is the same as that, this is the same as that. We're not actually solving problems here. We're just simplifying, combining like terms, writing things in a different form, kind of like we do with fractions and reducing them. So you're not getting an answer, you're just rewriting your answer in a different form. And one of the goals here is to learn all the correct forms for our answers. Fractions have to be in lowest terms. If you have variables that can be combined, there's a y, then you have to combine them to simplify it. And as far as it goes, you're not allowed to have negative exponents in your answer, which means if you solve a problem and you get a negative exponent, you have to flip it to make it positive. So if it was in the numerator, you would flip it and put it in the denominator. If it's in the denominator, flip it and put it in the numerator. So just be aware of that. Again, one of the goals of this lab is to review stuff you should already know and make sure we're clear on all the notation that we actually use in this class. Okay, good. Now we're going to jump to a couple of the problems on the back. So, the first one. So 3a, 4x, that's a terrible 4, 4x over xy times x over y. And I will point out, as I pointed out to my seated classes before, when you know what you're doing, you can simplify this at different times in different ways. If you know what you're doing, I'm completely fine with you simplifying. This thing can be simplified right at the beginning, and you'll still get the correct answer. Because my assumption is there's maybe some issues with this, I'm going to kind of do it the longer way just to make sure we're clear on all the algebra. But yes, you can do this faster if you're doing this on your own and you know what you're doing. So for the purposes of this, we're multiplying fractions. You multiply fractions straight across. If I had 2/3 times 5/8, I would multiply. 2 times 5 is 10, 3 times 8 is 24. I get 10 over 24. And then I would divide each of them by 2 and get 5 over 12. That's my simplified answer. Same idea here, multiply straight across. There's a 4, x times x. Multiply two exponentials together, add the powers. So that's x squared. On the bottom, there's an x. Y times y, same idea, is y squared. Now I try to reduce it. And right here, there's 2 x's on top, it's x squared, there's 1 x on bottom. So this x on the bottom will cancel one of the x's on top, and I'm just left with 1 x on top. And then there's a y squared on the bottom. Nothing else can cancel, So that's in lowest terms, and I'm good to go. Let's see, 3b. Two a minus b over x minus y times 3 times x minus y over 4a squared minus b squared. And as far as it goes, we're still multiplying, so we're going to multiply straight across. You can just multiply straight across and go from there. But as I've said, I think in other videos and in my seated classes, it is generally beneficial to factor things as much as possible and then try to simplify and combine and all of that once you have everything factored. So we're going to do that here. The 2a minus b can't be simplified, so I'm just going to write 2a minus b. Put it in parentheses because I don't want to combine anything accidentally. On the bottom, there's an x minus y, so just leave that there, times, there's a 3 times x minus y, and I'm just leaving all my parentheses. Here, that's a difference. Those are squared. 4 is a square, a squared is a square, b is squared, which means that's a difference of squares. So all of you know, difference of squares, a squared minus b squared is equal to, I used an x, a plus b times a minus b. So here, 4a squared minus b squared, the square root of 4 is 2, the square root of a squared is a, plus the square root of b squared is b, and then you flip the sign, 2a minus b. Now to multiply, just multiply everything across, and the good thing about multiplying these is you don't actually multiply anything, you just write it out. So you get a 2a minus b, then there's a 3, then there's an x minus y, over, there's an x minus y, there's a 2a plus b, there's a 2a minus b. And that's actually my answer, but as much as possible I want to simplify it, so I look for common terms. But there's an x minus y on the bottom, there's an x minus y on top, there's a 2a minus b on top, there's a 2a minus b on bottom, so all that cancels, and what's left over? The only thing on top is a 3, on bottom there's a 2a plus b. And then there's my answer in lowest terms. And one other thing I'll point out, it's not really important here, but if I somehow ended up with, say, multiple factors left over on the top or the bottom, you can debate whether you should FOIL that out and kind of write it out in standard form to make it simplified, or whether you should leave it in factored form. Personally, I don't really care. I like the factored form because you can see all the common factors and cancel them. But be aware, sometimes you'll have to FOIL it out, other times you'll leave it in factored form. It's pretty much problem specific for what we're doing. So make sure you can do things both ways. And maybe I'll find one more. Let's see. Oh, just to do one of the more complex ones, right at the bottom, number I. No, that's outside the board. Yeah, it is. So I, right here, we have 4 over a plus b minus 3 over b. And the way it works is, that looks really complex, but, well, I know how to work with fractions, and this is really just fractions inside of fractions. And there's kind of a mathematical way of looking at this. I want to simplify it. That's all we're doing with all of these things. We're multiplying them, dividing them, adding them, subtracting them, whatever, to simplify them and put them in an easier form, like a fraction, putting it in lowest terms. Same idea here. I want to simplify that. So there's a numerator and a denominator, simplify them separately, and then simplify the whole fraction. The denominator is just b, so who cares? Let it sit there. The numerator is 2 fractions, because this 3 I can write as 3 over 1. Now, combine those fractions, because that'll make it simplified. So if I want to subtract fractions, common denominator. That's an a plus b, that's a 1. So my common denominator is clearly a plus b. So now do the math that you all know. There's a 4 over a plus b minus 3 times a plus b all over a plus b all over b. Now do the math, distribute. And combine the fractions. There's a common denominator of a plus b, so I can combine them. And I get 4 minus 3 times a is minus 3a, minus 3 times b is minus 3b. And all of that is still over b. Move my equal sign here. Now I need to simplify that. I have a fraction over b, and once you understand what you're doing, you can do this in one step, but the idea is this b is really b over 1. Now I have a fraction over a fraction, and to simplify that, I just divide the fractions. I do the top, 4 minus 3a minus 3b over a plus b, divided by the bottom, b over 1. Now, that's division of fractions. How do you divide fractions? Keep, change, flip. So, I get 4 minus 3a minus 3b over a plus b times 1 over b. Now multiply across. That's just 1, so the numerator is going to stay the same. 4 minus 3a minus 3b. Here, to kind of go back to what I was saying here, if you want to multiply, make sure you distribute the b to both of these. You can, and you can write it in that form. I'm going to leave it in factored form, and I'll just get a times b, a plus b times b. And you can leave it like that, but again, if you want, you can distribute the b in and get ab plus b squared. Either form is fine. And now that's simplified, nothing else cancels, so I'm good to go. One other thing I will point out from a time perspective, and for those of you who've seen this before, right here when I have this, you can write out the division of the fractions, numerator divided by denominator, do the keep, change, flip, and you'll get the answer. Ultimately, what's actually happening, let's see if this one works. When you have a fraction over a fraction, numerators stay where they are, denominators flip. Meaning, this is the numerator of this fraction, so it'll stay on top. It did. This is the numerator of the bottom fraction, it'll stay on bottom. It did. These denominators on top and bottom flip. This 1 gets sent to the top and multiplied. This a plus b gets sent to the bottom and multiplied. So we got 1 times that, right here. 1 times that. And we got a plus b times b, right here. And again, you can always just write it out and get the answer. That is completely fine. But with practice, you realize, oh, I can just shortcut this and kind of flip my denominators and multiply. That's all the keep, change, flip actually does. So either one is fine. And again, I do stress for this and for some of these other ones, if you've done this before or you're kind of remembering it as you go, yes, I'm aware I could have simplified earlier and made this a little bit faster, but under the assumption that people are still learning it or whatever, I deliberately did this more long form so you can see every step worked out. But yes, if you know what you're doing, I am completely fine with you skipping a few of these steps to kind of simplify and solve the problem quicker. That's completely fine. I think this video is long enough. It's like 6 or 7 problems, I think. I don't know. So I'll post this, and if there's other problems you want me to see, either from this lab or another lab or from homework, just let me know, and I'll do that too.